Welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 chapter 5 complex numbers and quadratic equation. We are moving on to the last part of the chapter, it is miscellaneous exercise. So in the last video we discussed the first two miscellaneous exercise questions. Now we are moving on to the remaining questions. Next one, reduce 1 by 1 minus 4i minus 2 by 1 plus I into 3 minus 4i divided by 5 plus I to the standard form. To the standard form. So we have to reduce this into the standard form, means we have to make it in the form of a complex number. For that first we have to cross multiply this. So we will get 1 plus I minus 2 into 1 minus 4i divided by 1 minus 4i into 1 plus I into the next term is 3 minus 4i divided by 5 plus I. Now numerator can be written as 1 plus I minus 2 plus 8i divided by, opening the bracket, in the denominator 1, then plus I minus 4i minus 4i square is plus 4 into 3 minus 4i divided by 5 plus I, and that is equal to 1 minus 2 is minus 1 plus 9i divided by 5 minus 3i into 3 minus 4i divided by 5 plus I. Now again multiplying the numerator, then multiplying the denominator, we will get it as minus 1 into 3 is minus 3, then plus 4i plus 27i minus 36i square whole divided by 25 plus 5i minus 15i minus 3i square, and that can be written. Numerator is 3 minus 36i square means it is plus 6. So minus 3 plus 36, that is 33. Then plus 4i plus 27i is plus 31i divided by denominator 25 plus 3, because I square is minus 1. So minus 3i square is plus 3. 25 plus 3 is 28, then minus 10i. Now multiplying by the conjugate into 28 plus 10i divided by 28 plus 10i, which is equal to, again multiplying the numerator, 33 into 28, that is 924 plus 330i plus 31 into 28 is 868i, and the last term is minus 310. Then whole divided by 28 minus 10i divide into 28 plus 10i. So what is that? 28 square minus 10i square. So what we will get the answer? 28 square is 784, then minus 10i square is plus 100. Now the numerator 924 minus 310, which is 614 plus 1198i divided by 884, that is common, 2 is common in the numerator and denominator, that can be cancelled, and remaining the answer you will get it as 307 plus 599i divided by 442. So now it is in the complex number form. Now next one, convert into polar form. Convert into polar form. 1 plus 7i divided by 2 minus i whole square. So first we have to make in the form of the complex number. So 1 plus 7i divided by expanding a minus b whole square, that is 2 square is 4, then plus I square minus 4i, which is equal to 1 plus 7i divided by 3 minus 4i. Now multiply by its conjugate, that is 3 plus 4i, numerator and denominator, and we'll get it as numerator. If you are multiplying, we are getting 3 plus 4i plus 21i minus 28, because 7i square means 28 into I square is minus 1, then whole divided by 3 square is 9 minus 4i square, 4i whole square, that is 16i square, which is equal to plus 16, and that is equal to minus 25 plus I into 25 divided by 25. Now cancelling all the 25 in the numerator and denominator, we are getting it as minus 1 plus I. Now it is in the complex number form. Now we can convert into polar form, that is comparing with minus 1 plus I can be written as r into cos theta plus I sin theta. Then what is r? R is equal to root of minus 1 square plus 1 square, which is equal to root 2. And same way we have to find what is theta. For the tan theta we know that it is y by x, that is minus 1. So for which value of theta we are getting it as 1, that is for theta is pi by 4. And in which quadrant it is lying? X is negative and y is positive. It is in the second quadrant. In the second quadrant we have to take pi minus theta. So angle we have to take it as pi minus pi by 4, which is 3 pi by 4. Therefore in the complex number form we can write as r into, that is root 2 into cos 3 pi by 4 plus I sin 3 pi by 4. So this is in the polar form. So similarly in that one more question is there that you can do it as exercise, that you can practice it. That is question number, question is 1 plus 3i by 1 minus 2i. We have to convert into polar form, that you can try it alone. Now next one, solve some quadratic equations. We'll do one from that, and remaining 3 questions are there that you can try yourself. All it is in the same form. So 3x square minus 4x plus 20 by 3 is equal to 0. So in order to find out the value of x equal to minus b plus or minus root of 4ac minus b square into I divided by 2a. That's equal to minus of minus b means 4 plus or minus root of 4 into a into c, that is 4 into 3 into 20 by 3 minus b square, that is minus 4 square is 16 divided by, here I, 2 into 3, that is equal to 4 plus or minus, here 3 getting cancelled, remaining 20 into 4 is 80. So root of 80 minus 16 into I divided by 6, which is equal to 80 minus 16 is 64. So this is 4 plus or minus root 64. Root 64 is 8. 8i divided by 6, and that is equal to, in numerator and denominator we can see that 2 is common. So cancelling those 2 from numerator and denominator, we are getting the answer as 2 plus or minus 4i divided by 3, which is equal to 2 by 3 plus or minus I into 4 by 3. That is a solution. So similar way you have to complete. You have to try these questions. That is, question is x square minus 2x plus 3 by 2 equal to 0. These all to solve. Same way. Then next one is 27x square minus 10x plus 1 equal to 0. And another question is 21x square minus 28x plus 10 equal to 0. Now moving on to the next question. If Z1 is equal to 2 minus I and Z2 is equal to 1 plus I, find modulus Z1 plus Z2 plus 1 divided by Z1 minus Z2 plus 1. So we can substitute those values, that is modulus. Instead of Z1 it is 2 minus I, then instead of Z2 it is 1 plus I plus 1 divided by 2 minus I plus, here it is minus, so 2 minus I, then minus, in the bracket Z2 is 1 plus I plus 1, that is equal to modulus minus I and plus I getting cancelled, remaining 2 plus 1, 3 plus 1 is 4, divided by, here opening the bracket, 2 minus I minus 1 minus I, then plus 1. So plus 1 and minus 1 getting cancelled, remaining 2, then minus I is minus 2I. And we can see that 2 is common in the denominator, so that 2 can be taken out, that 4 can be cancelled here, so remaining 2 by 1 minus I. And we have to take the modulus, so 2 by modulus of 1 minus I is root of 1 square plus 1 square, which is equal to 2 by root 2, and that is equal to root 2. Now next one. Let Z1 is equal to 2 minus I and Z2 is equal to minus 2 plus I. Find real part of Z1 Z2 by Z1 conjugate and imaginary part of 1 by Z1 into Z1 conjugate. So first we have to find real part of Z1 Z2 by Z1 conjugate. For that, first we will find what is Z1 Z2 divided by Z1 conjugate. Z1 is 2 minus I, Z2 is minus 2 plus I divided by Z1 conjugate is 2 plus I. And that is equal to, we can open the bracket, so minus 4, then 2 into I is plus 2I, then plus 2I again, minus I square, whole divided by 2 plus I, and that is equal to I square is minus 1, so minus 4 plus 1, that is minus 3, minus 3 plus 4i divided by 2 plus I. Then we have to multiply by the conjugate. So that is equal to minus 3, that multiply by the conjugate means multiplying by 2 minus I in the numerator and denominator. So into 2 minus I by 2 minus I. Minus 3 into 2 is minus 6, minus 3 into minus I is plus 3i, then plus 8i minus 4i square. And that is equal to minus 6 plus 11i plus 4 divided by 4 plus 1. So that is minus 2 by 5 plus 11i by 5. Now the question is real part of Z1 Z2 by Z1 conjugate. Real part is, this is the imaginary part, this is the real part, so minus 2 by 5. Same way, one more question is there, imaginary part of 1 by Z1 Z1 conjugate. So imaginary part of 1 by Z1 Z1 conjugate is equal to 1 by Z1 is 2 minus I, Z1 conjugate is 2 plus I. So we have to find the imaginary part of this. So that is equal to imaginary part of this. First what you have to do, we have to multiply this the denominator, that is 1 by 2 square minus I square, and that is 1 by 4 plus 1, which is equal to 1 by 5. And writing in the complex number form, 1 by 5 only real part is there plus I into 0. So what is the imaginary part of 1 by Z1 into Z1 conjugate is equal to, imaginary part is 0. Then next one, find the modulus and argument. Find the modulus and argument of 1 plus 2i by 1 minus 3i. So we have to multiply by the conjugate 1 plus 2i by 1 minus 3i into 1 plus 3i by 1 plus 3i. Because first we have to write in the complex number form, then only we can convert into, we can find the modulus and argument. Now multiplying the numerator 1 plus 3i plus 2i plus 6i square, that is minus 6, divided by 1 minus 9i square, that is 1 plus 9, and that is equal to minus 5 plus 5i divided by 10, or can be written as all the 5 can be cancelled, so minus 1 by 2 plus I into 1 by 2. That is in the complex number form. Now we have to find what is r and what is theta. So r is equal to root of minus 1 by 2 whole square plus 1 by 2 whole square. That's equal to root of 1 by 4 plus 1 by 4, which is equal to root of 2 by 4, that is 1 by 2. And root of 1 by 2 is 1 by root 2. So that is r. Now we can find what is theta. For that we have to find what is tan theta. Tan theta is y by x. Y is 1 by 2 and x is minus 1 by 2. So we are getting it as minus 1. And we have to check in which quadrant it is. It is coming in the second quadrant. So as earlier that we have already discussed, in the second quadrant we have to take the angle as pi minus theta, and tan theta will be 1 for theta is equal to pi by 4. So argument is equal to pi minus pi by 4, which is equal to 3 pi by 4. So This is modulus and argument. Now next one, find the real numbers x and y. Next question, find the real numbers x and y if x minus iy into 3 plus 5y is the conjugate of minus 6 minus 24i. So first we can find what is the conjugate of minus 6 minus 24i. Conjugate of minus 6 minus 24i is equal to minus 6 plus 24i. Now we have to find what is x minus iy into 3 plus 5y. X minus iy into 3 plus 5y is equal to, multiplying this, 3x then plus 5i into x minus 3i into y minus 5y into I square, and that is equal to 3x then plus 5yx minus 3iy then plus 5y. So the real part is 3x plus 5y and imaginary part is I into 5x minus 3y. Now the question is, find the real numbers x and y if x minus iy into 3 plus 5y is the conjugate of minus 6 plus 24. So we have to equate these two. This is equal to minus 6 plus 24i. Comparing 3x plus 5y is equal to minus 6, and the second equation 5x minus 3y is equal to 24. These two equations we can solve. Solving by multiplying, we have any one coefficient should be same, so we can multiply this by 3, this by 5 and make the equations as 9x plus 15y is equal to minus 18, and this one 25x minus 15y is equal to, here 0, 120. Then adding these two, we are getting here 24 plus 9, that is 34x is equal to, here subtracting 102. Therefore x equal to 102 divided by 34, which is equal to 3, and substituting in the value any of this equation, will get the value of y. Y will be minus 3. X equal to 3 and y equal to minus 3. Now next one. Next question. Find the modulus of. Find the modulus of 1 plus I by 1 minus I minus 1 minus I by 1 plus I. So modulus of this means you have to find the that after making it the form of the complex number, you have to find the modulus. So for that we can cross multiply. So 1 plus I whole square minus 1 minus I whole square divided by 1 square minus I square. Its modulus we have to find. That is, expanding this, 1 plus 2i plus I square minus 1 minus 2i plus I square whole divided by 1 plus 1 is 2. That is equal to 1 plus 2i minus 1, then minus 1 plus 2i minus 1. Minus 1 into minus plus 1 whole divided by 2, and that is equal to 1 and minus 1 getting cancelled, so remaining 4i divided by 2, which is equal to modulus of 2i. Modulus of 2i means it is equal to root of 2 square, and that is 2. The number of non-zero, find the number of non-zero integral solutions. Integral solutions of the equation. Modulus of 1 minus I whole raised to x is equal to 2 raised to x. So modulus of something, that is root of. So this can be written as root of 1 square plus minus 1 square, that raised to x, equal to 2 raised to x. Then this is root of 1 square is 1 plus 1 square, so root 2. Root 2 raised to x is equal to 2 raised to x. That means root 2 raised to x means 2 raised to x by 2 is equal to 2 raised to x. So since the bases are same, powers we can equate. That is x by 2 is equal to x. Or that can be written as x minus x by 2 is equal to 0. Or that is x minus x by 2 equal to 0 means x by 2 is equal to 0 or x equal to 0. So there are no integral solutions. Now next one. If 1 plus I by 1 minus I whole raised to m is equal to 1, then find the least positive integral value of m. So given that 1 plus I by 1 minus I whole raised to m is equal to 1. Now first we can convert this into complex number form, that is 1 plus I by 1 minus I into 1 plus I by 1 plus I whole raised to m is equal to 1. That is numerator is 1 plus I whole square. 1 plus I whole square means 1 plus 2i plus I square divided by 1 square minus I square is 1 plus 1. That whole raised to m is equal to 1. That means here I square is minus 1. So 1 and minus 1 getting cancelled, remaining 2i. 2i by 2 whole raised to m is equal to 1. So 2 getting cancelled, we are getting I raised to m is equal to 1. And for which powers of m we are getting of I raised to m is equal to 1. So which power of m, what will be the value of m? So this m will be all multiples of 4, because I raised to 4, I raised to 8, etc. are these all equal to 1. But we need the least positive integral value of m, that means m is equal to 4. So that is all from that miscellaneous exercise, but we are having a few more things to study, that is square root. This comes in that supplementary material, very important part, square root of a complex number. Square root of a complex number. How to find the square root of a complex number? So we'll discuss that. That is, find the square root of minus 7 minus 24i. So in order to find the square root, we can equate this as x plus iy. Let x plus iy be the square root of minus 7 minus 24i. Let x plus iy be the square root of minus 7 minus 24i. So if I am squaring both sides, the square root will get cancelled. That means x plus iy whole square is equal to minus 7 minus 24i. Now expanding this, x square, that is a plus b whole square, x square plus 2i into x into y plus iy whole square is I square y square, that is minus y square, equal to minus 7 minus 24i. And this real part and imaginary part we can write together, x square minus y square plus I into 2x into y is equal to minus 7 minus 24i. Now comparing the real part, that is x square minus y square is equal to minus 7 and 2xy is equal to minus 24. So comparing the real and imaginary part, we are getting these two values. Now in order to get x and y, if here x square minus y square is there, 2xy is there. So we can apply in the identity x square plus y square whole square is equal to x square minus y square whole square plus 2xy whole square. So if you are applying in this identity, we can get what is x square plus y square. And if you are solving those two, we can get the answer. For that we are applying in this. So this is minus 7 whole square plus 2xy is minus 24 whole square. That is equal to 49 plus 576, which is equal to 625. So x square plus y square whole square is 625. So what is x square plus y square? Root of 625, that is 25. So one equation we are having x square minus y square, here we are having x square plus y square. So these two, if we are solving, this is first equation, this is second equation. We are solving these two equations, that is x square minus y square is equal to minus 7 and x square plus y square is equal to 25. Adding these two, this will be cancelled and this is 2x square is equal to here 25 minus 7. How much is 25 minus 7? That is 18. So x square is equal to 18 by 2 is 9. Taking the square root, we are getting x equal to plus or minus 3. Now substituting this in any of this equation, we can substitute in the second one, x square plus y square equal to 25. We'll get what is y square, that is 25 minus 9, which is 16, or y is equal to plus or minus 4. So we got the value of x as plus or minus 3 and we got the value of y as plus or minus 4. Now we should get the square root, that is we need to find the square root of a root of minus 7 minus 24i, and we know that it is x plus iy. That's already assumed. But one condition is there. Here we have got that 2xy is minus 24. So what is xy? It is minus 12. So product of two numbers x and y is minus 12, a negative value. So in order to get x and y, x into y as negative, one should be positive, one should be negative. So what will be the square roots? So first one you can take 4 minus 3i, or you can take minus 4 plus 3i. So these two are the so x is equal to plus 3i, sorry. So x equal to plus 3, then you have to take y equal to minus 4. So the one square root is 3 minus 4, right? And the other square root, other one it is possible as minus 3 plus 4i. These are the only two possibilities. So one more example we'll do from this to find the square root. So only to find the square root is there in the supplementary material, that we will complete it now. Another question to find the square root of minus 15 minus 8i. So let x plus iy be the square root of minus 15 minus 8i. Squaring x plus iy whole square is equal to minus 15 minus 8i. Expanding this, x square plus 2i into x into y minus y square is equal to minus 15 minus 8i. Real part means x square minus y square is equal to minus 15. Imaginary part 2xy is equal to minus 8. So we have to use the identity x square plus y square whole square is equal to x square minus y square whole square plus 2xy whole square. Substituting in this, minus 15 square, then plus minus 8 square. So that is equal to 225 plus 64, that is 289, and therefore x square plus y square is equal to 17. So we got two equations, x square minus y square is equal to 15 and x square plus y square is equal to 17. The other one is x square minus y square is equal to minus 15. So adding these two, 2x square is equal to 2 or x square is equal to 1. That means taking square root, x is equal to plus or minus 1. Same way we can find out what is the value of y. Substituting in the first equation, y square is equal to 17 minus 1, that is 16, or y is equal to plus or minus 4. And given that x into y is negative value, so the square root of minus 15 minus 8i can be written as, square root of this is either 1 minus 4i or minus 1 plus 4i. These are the square roots of this. So similarly, you can try for find the square root of minus 8 minus 6i, then 1 minus I and 1 plus I. It is in the same way you can proceed and practice all these types of questions. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.